Last lesson of Chapter 6. In 6.7 today, we're still going to be working with systems of equations, but not quite like we've done the rest of the chapter. In this lesson today, we're going to apply systems of equations to solve a new kind of problem. So we will use systems in this problem, but we're not just solving a system. We're doing more than that. So let's talk about what kind of problem we're solving today. Let's start right up here. In the past, you have gotten a problem like this, and you needed to combine those. And we've talked about how to do that, where you would get common denominators, simplify it all out, and then add the numerator. So like I would times this one by x minus 3 over x minus 3, and I times this one by x plus 4 and x plus 4. So then we have a common denominator of x minus 3 and x plus 4. There's our common denominator. And then once our denominator's common, then we can combine the numerator. So we have 3 times x minus 3, which is right here, plus 2 times x plus 4, which is right there. We distribute these to get that, combine our like terms, and we have that as our final answer. You've done things like this before. Now in this lesson, we're going to talk about how to work backwards. So what I'm going to do is I'm going to give you this, and we're going to end with this. We're going backwards from what we did. So let's talk about how to do that. Let's look at example 1 first. First step anytime you're doing this is you have to factor the denominator. This denominator is already factored, so we can quit that step. Step 2, we need to split up the fraction. Now, this is probably the hardest step of the lesson and something we'll be focusing on in each problem, is how to split up the fraction. So this one is not too crazy. I have 2 factors in the denominator, kind of like with what I had up here, 2 factors in the denominator. So essentially when I split it up, they're each going to get a fraction. So here's how I'm going to write this. I'm going to write equals a over my first factor plus b over my second factor. So then this way, I just need to figure out what a and b are, and then that's the individual fractions that I can combine together. Kind of like up here, I just need to figure out what a and b are. So then when I do combine them, I end with this as my final answer. So that is step 2, setting up the fractions. Step 3, we're going to multiply to get rid of the fractions. And this is something we've been doing all semester, which is multiplying by the denominator so that it goes away. So I'm going to multiply this one by x plus 1 and x minus 2. So then the x plus 1's go away and the x minus 2's go away. However, if I multiply this one by those denominators, I have to multiply everything by those denominators to keep it balanced. So I'm going to multiply this one by x plus 1, x minus 2, and this one by x plus 1, x minus 2. So now I've got that. Now what else can we cancel? Well, I can cancel an x plus 1 there, and I can cancel an x minus 2 there. So that is multiplying to get rid of the fractions. Step 4, write out what's left. So here I've got a 5x minus 1 that's left. Here I've got an a times an x minus 2 that's left. And here I've got a b times an x plus 1 that's left. So far, so good. Step 5, simplify. Simplify everything you can. Here I actually put simplify and organize. So I'm going to simplify everything. So this becomes ax minus 2a, and this becomes plus bx plus 1b. So there's my simplifying. Now here's what I mean by organizing. Organize your like terms. So everything that has an x, bring it together. So these two have an x. I'm going to bring them together. And everything that doesn't have an x, bring it together. So those two things don't have an x. Now that I've got this, now I'm going to take out or factor out any like terms that I've got. So step 6, factor out like terms. So both of these pink ones have an x in common. So I'm going to take the x out and I'm left with a plus b. Now I know normally you take what you factored out and put it in front. You would write it like this. I'm very specifically putting it behind instead of in front. You'll see why in just a second. And these two don't really have anything in common. So I'm just going to put them like that. So this is what I've got so far up to step 6. I have factored out my like terms. I've got this nice statement. Finally, step 7 is to set up your system of equations. Now here's what I mean by that. Notice that these two things are in front of an x. Well, if we go to the other side of an equation, I also have a 5 in front of the x, which means since these are both in front of the x's, they must be equal to each other. So we can say a plus b equals 5. Then you'll notice that this one doesn't have any x's, and these ones do not have any x's, which means these should be equal to each other. So I can say negative 2a plus b equals negative 1. And you'll now notice I have a 2 by 2 system of equations that I can solve for a and for b. So finally, step 8, solve system. Now, here's the good news. And on these problems on your test and final, I would never ever tell you what method you have to use to solve this system. You can use any method of your choosing. You just need to solve it. So what I'm going to do is I'm just going to use elimination because I noticed that if I subtract these two equations, the b's will go away. So a minus a negative 2a is 3a. B minus b goes away. 5 minus a negative 1 equals 6. So I get a is 2. Substitute that back into either equation. And I get b equals 3. So like I said, you can use any method you want to solve this system of equations. We've learned a lot of methods this chapter. I'm not going to dictate which one you have to use for these kinds of problems. You just have to solve it however you want to. Now that I have what a and b equal, my final step is to actually write out my answer. Your answer is going to be this equation you started with, except you're going to plug 2 in for a and 3 in for b. So I'm going to write 5x minus 1 over x plus 1, x minus 2 equals, plug 2 in for a, and then plug 3 in for b. And that's our answer. So if we started over here on this right-hand side, and I multiplied multiplied this by x minus 2 on top and bottom, and this by x plus 1 on top and bottom, and I FOILed all that out, this is what I would end up with. So basically, this is the working backwards. We've unsimplified this rational expression. So that is your first example of what we call partial fraction decomposition. we're decomposing a fraction into its pieces. In the next video, we'll try one where we actually have to do step 1 and we actually have to start by factoring the denominator ourselves.